But trust me, if you are going to deal with it step by step with the method we have learned in the previous 10 problems, it's gonna be easy. Hope you got the idea. This problem was exactly similar to the previous one. What did we learn is about the language. If they say something is happening at this rate, means the rate of occurrence is constant, and you can see that angle is acute angle. That angle is acute angle. What you need to understand here is that in the influence of AT, the speed will keep on increasing. Hey everyone, welcome back again, and today we are going to start our session of circular motion. Interestingly, we are not only going to start the circular motion topic, but today by investing a very good time, we are going to completely wrap up also. We are going to successfully complete this topic. So before I start with that, I would like to give you a brief idea regarding this session. So I have divided for your convenience the topic of circular motion into 4 different phases. Phase 1, we are going to talk about angular kinematics. Phase 2, we are going to talk about the kinematics of circular motion. Phase 3, we will talk about the dynamics of circular motion, and phase 4, we would like to talk about the conservation of energy in circular motion, emphasizing on vertical circular motion. Okay, so basically we are going to do the circular motion into 4 phases, and one by one, after having the brief idea of the concepts, we are going to complete the predictable problems for our actual exam, for our big day exam. Okay, so let's see, and I have selected 10 problems for each phase of our discussion. So after the completion of these 40 problems, be confident that you are going to crack accurately the questions of circular motion which we are expecting in the exam. Okay, so let us start with the first phase. That phase is angular kinematics. Angular kinematics. The way you are familiar with the basic terminology, distance, displacement, velocity, acceleration, speed in case of normal kinematics, in case of translational motion, same way we are going to get familiar with the parameters related to the rotational motion, or briefly you can call it angular kinematics. Okay, the equations are also going to be analogous. V equals to AT, S equal to UT plus half AT square. Those equations which you have already, which you are familiar with, a similar kind of set of equations you are going to find in case of angular kinematics. Okay, so let me take you first of all to the review of the basic concepts involved. All right, so first thing is we will try to define the basic parameters. The basic parameters are angular displacement, angular velocity, angular acceleration, and the equations for them. So if we define the circular motion can be considered as uniform circular motion and non-uniform circular motion. The circular motion can be classified as uniform circular motion. Uniform circular motion in terms of angular kinematics. In terms of angular kinematics, you can say this angular velocity. The basic thing is that I'll define few things for you. First of all, the way you have velocity as dx by dt, the same way you have differential equation, general equation of angular kinematics, that is angular velocity can be defined as d theta by dt. Angular velocity can be defined as d theta by dt. It is instantaneous angular velocity. Average angular velocity ke liye you can take it as delta. So big changes, the delta term will give you the average parameters. The small change in terms d theta by dt, these things are going to give you the instantaneous parameters. Similarly, alpha will be equal to d omega by dt. Time rate of change of angular velocity is called angular acceleration alpha. And the way we have the third general equation of motion as a equals to v dv by dx, similarly we would be having alpha is equal to omega d omega by d theta, just like a equals to v dv by dx. Why I'm writing it in front of you right now? So that you can establish a symmetry between the known kinematics and the angular kinematics. So uniform circular motion will be that type in which we will say the angular velocity angular velocity is going to be constant. Angular velocity is going to be constant and angular acceleration is going to be 0. So the equations which can be used to solve the questions based on uniform circular motion is omega instantaneous is equal to, omega instantaneous will be equal to d theta by dt, and omega average is equal to delta theta by delta t. Delta theta by delta t, theta final minus theta initial by t final minus t initial. Interestingly here, you will say since omega is constant, so definitely its instantaneous value and its average value are going to be same. Its instantaneous value and its average value are going to be same. So this is how you understand what a uniform circular motion is and what type of questions can come, what are the equations to be used to solve those type of problems. All right. Let us talk about the other one, that is obviously non-uniform circular motion. Now in non-uniform circular motion, again two cases arise. When we say that there will be some angular acceleration itself can be constant and angular acceleration itself can be variable. Which means here I would say that omega vector is going to be variable. Omega vector is variable. It may vary in magnitude, it may vary in direction, it may vary in both. But overall, who is responsible to vary the angular velocity is angular acceleration. So angular acceleration is going to be non-zero. Angular acceleration is non-zero, and that angular acceleration alpha only is responsible to change the angular velocity. That is responsible to change the angular velocity. We'll talk about it in detail. So further, if I want to classify, I can classify this into two categories where alpha will be constant and alpha will be variable. So what are the equations to be used? Just like uniformly accelerated motion, we had in that v equals to u plus at, s equal to ut plus half ad square, and v square equals to u square plus 2s. Similarly here also you can write it as omega final will be equal to omega initial plus alpha delta t. Theta is equal to omega initial into delta t plus half alpha delta t square. I hope you are able to relate that. S equal to ut plus half at square. And you have to use some convention. For example, in translational motion, in linear kinematics, I have told you that let us decide to take the vectors in such a way that all forward vectors are positive, backward are negative, upward is positive and downward is negative. So forward, backward, positive, negative. Upward positive, downward negative. Similarly in circular motion, let us stick with one convention that anti-clockwise can be taken as positive and clockwise should be taken as negative. Let us take the anti-clockwise vectors, anti-clockwise sense of rotation as positive and clockwise sense of rotation as negative. But remember, these are the sense of rotations. If I particularly talk about it, these are the sense of rotations. Direction of vector is perpendicular to it. Axial vectors, those are. I'll show it to you in a while. So before that, just like v equals to u plus at, you have omega final equals to omega initial plus alpha delta t. S equal to ut plus half ad square. Theta is equal to omega initial into delta t plus half alpha delta t square. And the third one is omega v square equals to u square plus 2as. So omega final square will be equal to omega initial square plus 2 alpha theta. Okay. And if the alpha goes variable, if your alpha is coming out to be variable, then you have three general equations of motion. V equals to dx by dt, a equals to dv by dt, and a equals to v dv by dx. Those three general equations are exactly in front of you. Omega is equal to d theta by dt, alpha equals to d omega by dt, and alpha equals to omega d omega by d theta, just like v dv by dx. I hope you got a clear-cut idea that ultimately your linear kinematics and your angular kinematics are going to be very much similar. Feel must be same. The way you feel the physics, The feeling behind that is exactly going to be same. All right. So what we will say here, suppose I comment about the sense of rotation. Sense of rotation. So we should be having the clear-cut idea that sense of rotation and direction don't mean they don't mean the same thing here. Sense of rotation and direction, they don't mean the same thing. So if you talk about the sense of rotation, then anti-clockwise should be taken as positive and clockwise should be taken as negative. Anti-clockwise conventionally can be taken as positive and clockwise can be taken as negative. But this is the sense of rotation. If we talk about the direction of the vector, rotational vectors, then you will say if that must be given by right hand thumb rule. This is given by right hand thumb rule. That means if you say that you take up your right hand in such a way that you curl the right hand fingers in the clockwise sense, the thumb is pointing inward. And if you curl them in the anti-clockwise sense, see the thumb is pointing outwards. Which means if the sense of rotation is anti-clockwise, which is taken as positive conventionally, then it is going to refer to a dot. Anti-clockwise, positive, it is going to refer to a dot. Dot means outwards. Dot refers to outwards. And on the other hand, if you want to talk about the clockwise sense of rotation, which I told you conventionally taken as negative, then that clockwise sense of rotation should be referring to the cross. Crossing means inward. I hope you got the idea. Means if the examiner is asking you a body is rotating in the clockwise sense, determine the direction of angular velocity. So you need to take up your right hand. You need to see that if the body is rotating in the clockwise sense, its angular velocity is directed inwards. Cross. Clockwise, cross. Inwards. Anti-clockwise, dot. Outwards. Don't forget to use your right hand. By mistake, don't take the left hand out. Okay. I hope you got the idea. So this was the basic introduction and the relation between the linear kinematics and angular kinematics. The analogy basically. What about the exact kinematics of circular motion in terms of centripetal acceleration, tangential acceleration, this, that? That's gonna be our next phase. We are going to talk about it later on. Okay. So, okay, let us start the discussion with the problems. And no, don't be in rush to copy the notes. Notes will be anyways provided separately to you. So after the session, you can copy down the notes. So watch the session carefully and try to get the best out of it, whatever you can understand. Okay. I will portray each and everything in front of you. I'll tell you so many details. So the first thing is first example. So phase 1, we are going to talk about 10 predictable problems. Be excited that something you can expect in the final exam exactly from the collection of these 10 questions in every phase. Question number 1, the position vector of a particle r vector as a function of time is given by this. So position vector is given by this, where r is in meters and I cap, j cap will tell you the direction, and then you have to comment about this motion. The path of the particle is a circle and you have to choose which of the following statement is wrong. In statement wise problem, always prefer to see whether the examiner is asking you what is correct or what is incorrect. So let us start our analysis. I will say that given format, just the concept I will brief you first. If position vector r vector is given as something a cos omega t I cap plus a sin omega t j cap, then it is going to represent a circle. Path is going to be always a circle. Path is going to be always a circle. Radius of that path is going to be equal to the coefficient a units, and center of such a circle is going to be origin. Origin means 0, 0. How do you say that, sir? How? I mean, you are telling the fact, sir, that okay, whenever it is written like this, we will take it as a circle. Should we remember this? Yes, you should remember this. But how? It's all about physics, not to memorize, but to understand. So what we will say here is, here x coordinate is given as a cos omega t. Given x coordinate as a cos omega t, a cos omega t, and y coordinate is equal to a sin omega t. If we square and add, here if you see, you want a relation, in order to comment about the path, you want a relationship between x and y. If you want a relationship between x and y, just eliminate cos square theta and sin square theta. How do we eliminate, sir? Cos square omega t plus sin square omega t is equal to 1. This implies x square by a square plus y square by a square is equal to 1, or you can simply say x square plus y square is equal to a square. So x square plus y square is equal to a square is a general equation of a circle whose center is at the origin and a is the radius. Whose center is at the origin and a is the radius. I hope you are familiar with it. Even if you are not familiar with this, suppose this type of problem you are looking at it for the very first time, let me brief you somewhat more. Suppose I precisely describe this equation, r vector equals to 4. This 4 is appearing in both the coefficients. I think I am allowed to take the 4 common. So it will be somewhat sine 2 pi t I cap plus cos 2 pi t j cap. Now if you look at it carefully, you can say whatever is the I cap coefficient and can be taken as x, and whatever is the j cap coefficient can be taken as y. So I will say here, in order to comment about the trajectory, how the particle moves, we want to eliminate any third variable except x and y. So which is the third variable except x and y? That's t. If we want to eliminate t, we will write sine square 2 pi t, see exactly the same thing which I have done over there, plus cos square 2 pi t, that is going to be equal to 1. Which means if that is the case, I can write it as x is basically 4 sin omega t and y is basically 4 cos 2 pi t. I repeat, x is not only sin 2 pi t, it is along with this, and y is also not exactly cos 2 pi t, it is also along with this. So I will say sin square 2 pi t can be written as x by 4 ka whole square, x by 4 ka whole square. I repeat, x can be written as 4 sin 2 pi t. So sin 2 pi t can be written as x by 4. Same with y. So this is y by 4 whole square equals to 1, or that can be written as x square plus y square is equal to 4 square, or maybe 16, naturally. So this is going to graphically represent what? This is going to graphically represent the equation of uniform circular motion. It is going to represent the equation of UCM, uniform circular motion. Now onwards you can remember this. That's why I have described it 2 times. Okay. Even if this is the first time you are looking at it, now onwards you can understand it and remember this, that whenever you see such kind of equation, it is going to represent the standard equation of uniform circular motion. And if it is going to represent the standard equation of uniform circular motion, you can imagine it that the particle is in such kind of circular motion whose, I'll take exactly the same shape which I want, whose center is exactly or at the origin, 0, 0, and whose radius is going to be 4 units. Okay, 4 units. So these points are 4, 0, minus 4, 0, and that's 0, 4, minus 4, and this is 0, 4. Okay. Now, what we have understood on the entire slide is that how to identify the standard equation of a uniform circular motion, or else what extra knowledge we have gained is that whenever examiner will give you something in terms of sin 2 pi t, cos 2 pi t like that, if you want to comment about the trajectory, if you want to comment about the path, always prefer to eliminate the third variable, means 2 pi t variable you should eliminate, and try to establish a relationship between x and y, because the equation between x and y are ultimately going to give you the equation of trajectory. Always remember, equation of trajectory must be in the form of x and y, or 3-dimensional motion, which is not in our syllabus. In that it would have been in terms of x, y, z. Okay. Now coming back, path of the particle is a circle of radius 4 meter. That's true. That's true. Acceleration vector is along minus r. That is also true, sir, because if position vector is radially outwards, the only acceleration is centripetal acceleration. Centripetal means center seeking, towards the center. Centripetal acceleration is towards the center, radially inwards, and position vector is radially outwards. So you will say that is also true. Remember dear, they are not asking you which one is correct, they are asking you which one is wrong, incorrect. See, magnitude of the acceleration vector is v square by r, true. Centripetal acceleration, where v is the velocity of the particle. So that is also true for us. True. Magnitude of the velocity of the particle is 8 meter per second. Magnitude of the velocity is 8 meter per second. I think we have to find it, but obviously that would be wrong. That would be wrong. I will tell you why that will be wrong. I'll tell you. Without solving, how you can comment about the answer, sir? Because they were asking us wrong and the first three statements were found to be correct. So naturally the fourth one will be the wrong one. Okay. Let me find this out for you. So I have taken a copy for that, and now I'll tell you how to talk about the velocity. Okay. So I think, okay. Yeah. I'll just remove the not required quantities from here. Yeah, this is the equation, this is the case given to you. Let me solve it further. Suppose they are asking you v vector. Can I write v vector will be equal to dr vector by dt? Okay, you have to differentiate dr vector by dt. So if you are going to differentiate this, what I am going to get is, I will say 4 will stand as it is. Sine 2 pi derivative is going to be cos 2 pi t, but don't forget to multiply with the coefficient of t 2 pi. Why you are multiplying with this particular coefficient, sir? Why you are multiplying with this coefficient, this particular coefficient 2 pi? I will say chain rule of differentiation. Out of you whosoever doesn't understand what the chain rule of differentiation is, whenever you are differentiating, that's okay. Sine's derivative is cos derivative is minus sine. But always you have to multiply with the coefficient of the variable. So what is the coefficient of the variable? Sorry. What is the coefficient of the variable? The t is the variable, its coefficient is 2 pi, so you are going to multiply with it. Now similarly, cos 2 pi derivative is minus sine 2 pi. Okay, and you are again going to multiply with the coefficient of this 2 pi, that's j cap. Is it fine? So ultimately, if you are going to solve it, how do you solve it? You will say the same. So if you take the 2 pi common here, then what you will get? You will get this v vector as 2 pi taken common, 4 into 2 pi, and this is cos 2 pi t I cap minus sine 2 pi t j cap. All right. So at least see 8 pi is already there outside, and then you will take its resultant magnitude cos 2 pi t I cap minus sine 2 pi t j cap, which will give you further root 2. So definitely the answer is not going to be the fourth option. So fourth option is wrong, and yes, you had to select the wrong one. I hope you got the idea. Yes, I took you a bit ahead in multiple steps in this particular problem, because this was the first introductory problem in which I wanted you to realize that the moment next time you will see this particular equation, you can clearly say that's the equation of uniform circular motion. But at the same time, you are supposed to know the background. Why the background is to be known, sir? Why can't we, if we already know that we are dealing with uniform circular motion, what is the importance of all this stuff? The importance is, the moment they will vary this coefficient, one is 4 and another one is 5, you will not be ending up dealing with a circle. You will be in that case ending up dealing with an ellipse. How that's so? We can take it in a while. Okay. But let me take you towards the next problem now, and don't rush in copying the solutions. Notes will be separately provided. Okay. So another one, So now what you have is a particle moves in the xy plane, similar to the previous one. A particle moves in the xy plane, and according to the rule x equals to a cos omega t and y equals to a sin omega t, you have to comment about the path followed by the particle. So just now I have told you this, that given x equals to a cos omega t or cos omega t from here, that can be written as x by a, and y equals to a sin omega t. And if you want to comment about the path, sir, then you have to get an equation in terms of x and y. So definitely you are bound to eliminate the third variable. For example, the third variable here is t. So now, in order to eliminate the sin t and cos t function, we will apply a basic trigonometric identity that cos square omega t plus sin square omega t is equal to 1. That means you can write it as x square by a square plus y square by a square is equal to 1. So you will say that is x square plus y square is equal to a square. See, another time that is in front of you. So it's a circle. It's a circle having radius a units and center at 0, 0. Having radius a units and center 0, 0. Suppose, on the other hand, suppose they say that x equals to a cos omega t and y equals to b sin omega t. X equals to a cos omega t and y equals to b sin omega t. Notice that earlier the given question is already in front of you, that you are dealing with a circle. You are dealing with a circular path. But suppose I have to justify that when the answer will be an elliptical path, say. So for elliptical path, I am going to give you another condition, that x equals to a cos omega t and y equal to suppose b sin omega t. Then you will say that again, if you write cos square omega t plus sin square omega t, which is on a it is a standard identity that's gonna be 1. You can write it as x square by a square plus y square by b square. It is going to be equal to 1. So x square by a square plus y square by b square equals to 1. Everyone knows that's the equation of ellipse. And how it is going to look like, sir? How it will look like? So this ellipse will look like this, that x-axis, y-axis, and the elliptical form is this. Length of semi-major axis is a, length of semi-major axis is a, and length of semi-minor axis is b. Length of total minor axis is 2b, or the coordinates which you can say here. This is 0, b, this is 0, minus b, this is minus a, 0, and this is a, 0. Okay. So this is going to be the shape of the ellipse you are dealing with if the coefficient a and b are going to be different. Okay. I hope you got the idea that again how to identify circular motion, and again that's the equation of particularly uniform circular motion. Okay. Have you understood? Okay. So let me take you to another problem now. Another thing is two particles, another problem model. I hope you remember that I have taken 10 predictable models, out of which we are already on the third one. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed V and VB respectively. Radii are given, velocity speeds are given, and uniform circular motion is given. Uniform circular motion. Their time period of rotation is the same. Their time period of rotation is the same. So I would say what they are giving. Given time period of A must be equal to time period of B. Or you can say time period can be what they are actually asking, the ratio of angular speed of A to that of B. I hope you remember that time period can be written as 2 pi by omega. So that is 2 pi by omega A must be equal to 2 pi by omega B. From here, omega A by omega B, that is equal to 1:1, irrespective of the radius and speed. Irrespective of the radius and speed. Hence the correct option is 1:1. So sometimes in this type of question is going to be very easy, but sometimes in this type of question, students get confused thinking, yaar, where I am using the data R and VB, we have to use the data. No dear, such a question In such problems, these data are redundant data, useless data. Those are just given to confuse you. Otherwise, the solution is going to be quite simple. Alright, chaliye. Problem number 4, another problem model. The angular speed of a flywheel making 120 revolutions per minute is. So the angular velocity is in revolution per minute, RPM, but that is required in RPS, radian per second. So what you can do here, angular velocity omega, this is 120 revolutions per minute. 120 revolutions per minute. Now you are bound to change it into radian per second. So that can be written as 120. See, that can be written as 120. One revolution can be written as 2 pi radians. One revolution can be written as 2 pi radians, and 1 minute can be written as 60 seconds. 60 seconds. So it's like a rule. The way you have speed in kilometer per hour, and you want to change this speed into say meter per second, then what you are supposed to do, you are supposed to multiply with 5 by 18. 5 by 18. Okay. And similarly, if you have it in meter per second and you are going to convert it into say kilometer per hour, then you are going to change it. You are supposed to change it in meter per second to kilometer per hour by multiplying it with 18 by 5. Multiplying it with 18 by 5. I hope you understood what I am talking about. So basically, this is all about the conversion which you already know. Similarly, I am dealing with another conversion for you. I am saying if it is in revolutions per minute, if it is in revolution per minute and you want to change it into radian per second, then you have a habit of multiplying it with 2 pi by 60. Okay, revolutions per minute into 2 radian per second, multiply it with 2 pi by 60. And if you want to convert this radian per second into revolution per minute, then you have to multiply it with naturally 60 by 2 pi, opposite to this. So basically the rule is that the radian per second is SI unit. This radian per second is basically the SI unit of omega. Okay, SI unit of omega. That's why our preference is to convert it into radian per second. Okay, now you have to just solve it. So what will be the answer? 60 will cancel 120 at 2 times into 2 pi. The answer is 4 pi radian per second. 4 pi radian per second. So the correct option is, I think, option A, 4 pi radian per second. Okay, so remember the basic rules: kilometer per hour into meter per second, 5 by 18, meter per second into kilometer per hour, 18 by 5. Revolutions per minute to radian per second, revolutions per minute to radian per second, 2 pi by 60, radian per second to revolutions per minute, 60 by 2 pi. Or you can say divide by 2 pi by 60 instead of multiplying. Okay, so that's the thing. Let me take you to another problem. Problem number 5. Two particles having mass capital M and small m are moving in a circular path having radius capital R and small r. If their time period are same, the ratio of their angular velocity will be. I told you earlier that initially two problems back also we solved this sort of question, in which the time period came out to be independent of radius and speed. And this problem is teaching it is again coming out to be independent of mass. Coming out to be independent of mass. They are saying they are moving in a circular path having radius capital R and small r. Their time periods are same. So here time period of small m will be equal to time period of capital M. Time period of small m can be written as 2 pi by omega of small m. That will be 2 pi by omega of capital M. This implies the ratio of omega of small m by omega of capital M is again going to be 1:1. So two problems back we have learned that the time period is coming out to be independent of radius, independent of speed, and now we have learned it is coming out to be independent of mass. So let us conclude that it is coming out to be independent of mass, radius and speed. Mass, radius and speed. Okay ji? So that is 1:1 once again. Okay. So now suppose in the same question they ask you that if their time period are same, the ratio of their angular velocity, okay, I'll modify it in the rotational motion. Let me talk about another problem now. I'll modify this particular question in rotational motion and gravitation for you in order to learn further physics. Right now what is happening, the angular frequency of a fan increases from 30 rpm to 60 rpm in pi seconds. Notice that they are not dealing with the SI units. They are not dealing with the SI units. What you can say is omega initial is given to you how much? That is 30 rpm, or you can say 30 into 2 pi by 60. 30 into 2 pi by 60 radian per second, that is the SI unit. Or you can say 30 into 2, 60 and 60 will be cancelled, it will be pi radian per second. Okay. Omega final is equal to 60 rpm, or you can say that can be written as 60 into 2 pi by 60 radian per second, or you can say 2 pi radian per second. Okay, so we have got the initial one, we have got the final one. Now what else? In pi seconds, so delta t time is given to you as pi seconds. A dust particle is present on the blades at a distance of 20 centimeter from the axis of rotation. The net acceleration of dust particle at the end of pi seconds is, they are asking you the net acceleration at the end of pi seconds. So first of all, we have to find out the alpha. The alpha value will be equal to omega final minus omega initial by delta t. So that is equal to 2 pi minus pi by pi. Okay. So that will be equal to, you can see that is 1 radian per second square. Okay. Omega final minus omega initial by delta t, everything is in SI units. Now by the help of alpha, we get tangential acceleration. Be prepared, this problem is going to be very interesting. AT, tangential acceleration, is basically R alpha. The radius is how much? 20 centimeters, 20 by 100. The radius is 20 centimeters, 20 by 100, because that's the distance from the axis of rotation. And alpha you have calculated 1. So it is going to be 20, I think 0.2 meter per second square, 0.2 meter per second square. Similarly, if you are going to calculate centripetal acceleration AC, that is V square by R or omega square R. V square by R or omega square R. That will be a variable one, but they are asking you at a distance of, at the end of pi seconds. So at the end of pi seconds, it is going to be omega final ka square R. Omega final is 2 pi. That's 2 pi square into 20 by 100 because of 20 centimeter radius. Okay. So that is going to be 0.2, and if you look at it carefully, it is 2 square 4 pi square. I think pi square can be approximated as 10. I'll simplify it for you. See, 20, this 0 will be cancelled. Okay, so that will be equal to 2 ka square 4, that's pi square into 2 by 10. Now I am saying this pi square is approximately equal to 10. Pi square is approximately equal to 10, so that's going to be 4 into 2, 8 meter per second square. 8 meter per second square. Now if you notice, you got tangential acceleration. If you notice, you got centripetal acceleration. So tangential acceleration to centripetal acceleration, both are in front of you. If you need the net acceleration, that is under root of AT square plus AC square. Today we are going to discuss a lot of models based on this AT square plus AC square. So that is equal to under root of tangential acceleration is how much? 0.2. 0.2 square plus that's almost 8 square. So it is going to be resulting in under 8 point something. So I think the correct answer should be, what you can take? 8 point something, nearby shayad maybe 7.9 only, because I have approximated pi square as 10. In fact, I would say that this type of question you need to be prepared. Sometimes exactly in the same problem model, they are only and only asking you the tangential. So tangential, how do we calculate? We have calculated alpha. R into alpha is going to give you the tangential acceleration. So for those type of problems, your answer is only 0.2. Sometimes in such a question, they will be asking you only centripetal. So your answer could be 7.7 or 8 because we have considered some sort of approximation. But yes, if they ask you the net acceleration, then you have to do it like this. Okay. So here, depending upon the set of options, I would like to safeguard my opinion with option B. Option B, and that is the data for centripetal, which is also called as normal acceleration, which is also called as radial acceleration. Okay. Centripetal acceleration, normal acceleration, or radial acceleration. So somehow by this problem we have learned what types of acceleration do exist in case of circular motion, and whenever we use a common relation A equals to R alpha, then what is that A over there? That A is not the net acceleration here, that A is not the centripetal acceleration here, that A is precisely the tangential acceleration there. Okay, I hope you got the idea. Have a look of every part I have done in the problem, step by step. Then I'll take you to the next one. Okay, I hope that's fine for you. Chaliye, depending upon the options, you should choose which type of acceleration it is exactly. Example 7. A particle P is moving in a circle of radius A with uniform speed V. C is the center of the circle and AB is a diameter. I think I should keep on drawing the diagram according to what they say. They say particle P is moving in a circle of radius A with a uniform speed V. C is the center of the circle and AB is the diameter. So let us consider AB as a diameter. AB as a diameter. So this is AB, the diameter. The dia A and B, and this is going to be the center C. Okay, the radius is given to you as A units, and velocity is V. The angular velocity of the particle when it is at point B, about A and C are in the ratio. So when it is point B, the particle is somewhere here. Let me change the initial so that it will be better for us. It will be easy for us to understand. So let me take this A there and B here, and imagine there is the particle. Imagine there is the particle here. It is moving with velocity V, and you have to find out its angular velocity when it is point B, about A and about C. So if you want to find the angular velocity about A, then you have to find out the radial distance. The radial distance about point A is going to be the 2A, the actual diameter. Radial distance about point A is going to be the diameter of the circle, and radial distance about point C is going to be the radius of the circle. Okay, I repeat, the radial distance means the distance which is the distance of the line joining the point to the velocity vector. The radial distance about point A is going to be the diameter of the circle 2A, and radial distance about point C is going to be this distance, that is the radius of the circle A. So if they are asking you here, the actual question what they are asking you is that angular velocity ratio. So here they were asking you angular velocity of the particle when it is at point B, about point A, and angular velocity about point C, about point A and about point C. So angular velocity can be written as V by R. Tangential velocity is V, but radial distance about point A is 2A, and here it is tangential velocity V, and radial distance about point C is A. So yes, the final answer is 1:2. 1:2. Option B is an appropriate one. Option B is the appropriate one. I hope you are done with the logic. I hope you understood what I have done. See, basically whenever you write L equals to R theta, whenever you write L equals to R theta, where L is basically the arc length, right? Arc length. So once you differentiate it with time, we get V equals to R omega. This V is tangential velocity, that is radial distance into omega, angular velocity. And when you again differentiate it, you get AT equals to R alpha. AT equals to R alpha. So on the previous question we have learned, when you write A equals to R alpha, precisely that should be the tangential acceleration. Similarly here you can say that is tangential acceleration, tangential velocity and tangential length, which is commonly called as arc length. I hope the idea is clear to you. है ना? So hope you have understood this problem. So we are done with 70% of our journey with the phase 1. Phase 1, that is angular kinematics. Let's see some more different models. Next question is, starting from rest, a wheel rotates with an uniform angular acceleration 2 pi radian per second square. After 4 seconds, if the angular acceleration ceases to act, after 4 seconds, if the angular acceleration ceases to act, stops to act, ceases to act, its angular displacement in the next 4 seconds. I will discuss it into two different intervals. I will say first 4 seconds. First 4 seconds. First 4 seconds, it's uniformly accelerated situation. What is given to you? You will say it starts from rest. So omega initial is going to be 0. Uniform angular acceleration alpha will be equal to 2 pi radian per second square. This is 0 radian per second. The time delta t is equal to 4 seconds. So you will say omega final will be equal to omega initial plus alpha delta t. So that is going to be 0 plus 2 pi into 4, and hence the final answer is 8 pi radian per second. 8 pi radian per second, it's kind of uniformly accelerated. It's kind of uniformly accelerated. Now what will happen? Next 4 seconds. In the next 4 seconds, it ceases to act. The acceleration ceases to act. So you will say your omega is going to be, like, since alpha is going to be 0 radian per second square, I will say omega will be constant, and that constant omega which you have already attained, that is that omega which you have already attained. You have already attained the 8 pi. So the body will keep on moving with that 8 pi. And now you will say what will be theta then? Then theta will be equal to omega into t, or you can say omega into t, omega into delta t plus half alpha delta t square, out of which this alpha is going to be 0. This alpha is going to be 0. So that's 8 pi moving for 4 seconds, and hence the answer is 32 pi radians. 32 pi radians. So the correct option is fourth option, that is 32 pi radians. Okay. In the same problem, if number of oscillations are required, like they are not number of rotations or number of revolutions are required, they are only asking you theta, angular displacement. They are asking you angular displacement. If they ask you the number of revolutions, so you will say number of revolutions can be written as theta by 2 pi. Okay, in 2 pi revolutions, there in 2 pi radian there is 1 revolution, so that's gonna be 32 pi by 2 pi, and hence the answer should be 16 revolutions. So in the similar question, if they ask you the number of revolutions that is covered by the particle in the next 4 seconds after the angular acceleration ceases to act, then the 16 is going to be your final answer. Alright. So this is how you have to deal with it. Normal, uniformly accelerated motion, then it is a kind of uniform motion. Distance is equal to speed into time because acceleration is 0. Like that, sort of that kind of problem it is. I hope it is clear. Alright. Chaliye, taking you for the next one. Again, this is also a simple problem, and in the final exam also you can expect simple problems for you. So second last problem for us for the phase 1. The speed of a motor increases from 1200 rpm to 1800 rpm in 20 seconds. 1200 rpm to 1800 rpm in 20 seconds. How many revolutions does it make in this period of time? It's similar to what I have told you just now. So let us start with that. Omega initial will be equal to 1200 rpm. Omega final will be equal to 1800 rpm. I would say find the delta omega. Delta omega will be equal to, and it's not talking about the alpha value. Okay, let me take it alpha value. So delta omega will be omega final minus omega initial. So that is 1800 minus 1200, that is 600 revolutions per minute. Better to multiply it with 2 pi by 60. So 600 into 2 pi by 60, 2 pi by 60, radian per second. So that will be 60 will cancel 600 at 10 times. So it's going to be 20 pi radian per second. That's the change in velocity. So finally, if I want to get the value of alpha, the alpha is going to be delta omega by delta t. Delta omega by delta t. So that is 20 pi by the delta t. Delta t is given to you as 20 seconds. 20 seconds. So that will be pi radian per second square. Pi radian per second square. Now what examiner is asking you? The examiner is now asking you how many revolutions does it make in this period of time. So I will say, first of all, let us try to find theta. Theta is equal to omega initial t plus half alpha t square. Half alpha t square. So you will say omega initial t. Omega initial is how much? 1200 into 2 pi by 60. 2 pi by 60 and into t, that is 20 plus half alpha. What you got is pi square, pi into t square, that is 20 ka square. That is how you will get the value of theta in radians. So we can simplify that. Theta in radians will be 60 will cancel. I think I can cancel 20 60 by 20, that is 1 by 3. 3 will cancel 1200 at 400 times. 400 into 2 pi, I think it is 800 pi, plus it is 400 by 2, 200 pi, and ultimately you are getting 1000 pi. So number of revolutions is equal to theta by 2 pi. That's what I have told you on the previous slide. So that will be 1000 pi by 2 pi, and hence that will be equal to 500. So the correct answer is 500. But sir, do we really have to do this much in the final NEET exam? I would say no. The question is relatively simpler. One way of doing it is step by step, whatever you are having in front of you, and never stop in between. Keep doing it just like you do solve the normal kinematics questions. But what can be done extra here is, you will say, or way two of doing it. When you have theta initial, theta final like that, for if alpha is constant, just like in uniformly accelerated motion you do, then we can write it as theta is equal to omega final plus omega initial by 2 into delta t. I mean, this can be written as omega average, initial plus final by 2. So it is 1200 rpm revolutions per minute plus 1800 revolutions per minute by 2. 1200 by 1800 revolutions per minute by 2 into delta t. So if it is in revolutions per minute, be careful. If it is in revolution per minute and you need the answer in revolutions, then you should be multiplied with time, which is in minute. I repeat, if it is given in RPM and you need the final answer in revolutions, then not to do this much. You can avoid doing this much by multiplying the time in terms of minute. So see, it is 20 seconds given. If you want to convert it in minute, then it is 20 by 60. 20 by 60 in minutes. I hope you are getting the idea. I'll just give you the highlight once again. What I am telling is, let's play with the units. You are multiplying the RPM. Better to multiply revolution per minute into minute, because you need the final answer in number of revolutions. So see, 20 by 60 is 1 by 3. 1800 plus 1200 is 3000. 3000 by 2. 3000 by 2, it is 1500. 1500 into 1 by 3. 1500 into 1 by 3. Final answer you are going to get 500 revolutions. 500 revolutions. So if you try to use the average speed technique as well as play a bit with the units, definitely you can save a lot of time from this standard procedure. But yes, to be precise, the standard approach has to be this one. Take a minute to see each and every step in front of you. See that carefully, each and everything. It is quite related to what do you do generally in translational motion. Hope that's okay. All right. Let me take you to the last problem of this phase. This is the problem for you. Already a PYQ also. Majority of the questions are from different exam, and yes, from the collection, which is expected to be probable for the main exam. A particle starting from rest moves in a circle of radius r. It attains a velocity v0 meter per second in the nth round. Its angular acceleration you need in radian per second square, that's the SI unit. SI unit is of alpha is radian per second square, you need everything in SI units. So what I can write here is, I can write V1 if I start from the linear kinematics things, because V0 is given to you. So I will write V equals to U plus AT, where A can be written as tangential 1, or rather I would like, because they are not interested in time, they are interested in the displacement, nth round. So I will be writing it as V square equals to U square plus 2AS. V square equals to U square plus 2AS. Final velocity is V0, that's V0 square. Initially it started from rest, so 0 square plus 2. Tangential acceleration can be written as R alpha S. They say nth round. Nth round means the displacement covered in, like, treating the circular one into the linear one, the total distance it will travel is n into 2 pi r. Okay, that's the situation. So you got V0 square as 2, I got 4 r square, 2 into 4 r square pi n alpha, or you can say alpha from here will be V0 square by 4n pi r square, So V0 square 4n pi r square, I think the correct option is option 1. V0 square by 4n pi r square. Okay, this is the one way of doing the same problem. Way 2, if you want to do not with the linear kinematics one, but the angular kinematics, then also you can do the same. You can write omega final square will be equal to omega initial square plus 2 alpha theta. Omega final is V by R. So that is V0 by R and its square. That will be 0 ka square plus 2 alpha. Theta can be written as n into 2 pi. From here, if you need the value of alpha, I think alpha will be equal to V0 square by 2 into 2, that is 4n pi, and it is r square already. Again, what you got is alpha is equal to V0 square by 4n pi r square. I hope you got the idea. So exactly the same question, but it involves a linear parameter V and angular parameter alpha. So no need to worry about it. In fact, it gives you the versatility in solving the problem, that either you can start your discussion with the translational approach, or you can start the discussion with the rotational approach, way 2. Alright. So finally with this completes the phase 1 of the discussion, that is the angular kinematics. Very soon we are going to start with the second phase of circular motion, that is going to be the kinematics of circular motion. Now we are going to start with our phase 2, that is kinematics of circular motion. So as of now we have already seen some problems based on angular kinematics. So what's going to be new in this particular session? So yes, here we are going to talk about centripetal acceleration, tangential acceleration in a circular motion, how to find and what is the role of centripetal acceleration, how to find out, and what is the role of tangential acceleration. And yes, after considering the centripetal as well as tangential, we would be able to comment about the net acceleration, the angle formed by net acceleration with velocity vector, the work done in a particular circular motion as positive, negative, or 0, the power delivered is positive, negative, 0, whether there will be a change in kinetic energy or not. All these aspects we are going to discuss in case of circular motion kinematics. So without taking much time, let us go through the basic concept, what is involved in this part of circular motion. So first of all, I would say that let me brief regarding what type of accelerations are there and what is the role of acceleration in case of circular motion. So we know that a velocity vector can be written as its magnitude as well as its direction. Suppose we differentiate with respect to time. Differentiating with respect to time. So if we differentiate with respect to time, what we are going to get, dv by dt, that will be equal to, by product rule we can differentiate that first function is as it is, and dv cap by dt plus mod d of mod v by dt, which means the magnitude is changing with time and the direction is the same. So if you look at it carefully, dv vector by dt means the acceleration which is responsible to change the complete velocity vector, that can be written as net acceleration. Next term is basically that acceleration which is responsible to change only the direction. The direction is changed by the centripetal acceleration, which is also called as a normal acceleration or radial acceleration. Centripetal acceleration, normal acceleration or radial acceleration. And the third term is that term in which the magnitude is changing with time, which means that acceleration which is responsible to change only and only the magnitude of velocity. That acceleration is tangential acceleration. So what we got to know is that in case of a circular motion, there can be three types of acceleration. Centripetal acceleration is responsible to change only and only in the direction, Tangential is responsible to change only the magnitude, and net acceleration is given by both of them. These don't interfere. They don't interfere in each other's operation. So these are going to be independent in operation. In operations means, I will say, what is the function of centripetal acceleration or normal acceleration, or you can call it radial acceleration too. Its responsibility is to change only the direction. It only changes direction. And tangential acceleration only changes magnitude. So everyone we know that magnitude may or may not be changed, but the direction, whenever a particle is moving in circular path, its speed, the velocity's magnitude may or may not be changed, but direction will surely change. Okay, so centripetal acceleration will be surely there, but tangential acceleration may or may not be there. When tangential acceleration will be there? When there is a change in magnitude, means change in speed. And when tangential acceleration will not be there, when there is no change in speed. Alright, makes sense? So now what's going to happen, that we will try to find out tangential, centripetal, and then we are going to calculate the net one. So how to find out both of them? So first thing is, we can take it as tip 1. Second thing, tip 2. How to find out both of them or all of them, all type of acceleration. So we will say, if we want to find out the centripetal acceleration, its formula is v square by r, or that can be written as omega square r. V square by r or omega square r. Tangential acceleration can be written as dv by dt, or can be written as r alpha. And net acceleration is given by under root of ac square plus at square. Net acceleration is ac square plus at square. Sometimes that can be written as under root of, see, you can write it as omega square r ka whole square plus r alpha whole square. So naturally r can be taken common, and it is under root of omega to the power 4 plus alpha square. So that is the expression of net acceleration which you can get in terms of in the case of circular motion. Centripetal acceleration is always there in circular motion. Because its responsibility is to change the direction of velocity, and direction of velocity will surely be changing in case of circular motion. Tangential acceleration will not be present. In uniform circular motion. So in uniform circular motion, the speed of rotation is not changing, and the responsibility of tangential acceleration is only and only to change the speed. Only and only to change the speed. If we take this net acceleration in case of UCM, uniform circular motion, in case of UCM, the net acceleration will be equal to under root of AC square plus AT square, out of which the tangential acceleration will be 0. So that will be AC or omega square R or V square by R. So what is the, like, omega square R is the formula of what, sir? Omega square R or V square by R is the formula of centripetal acceleration, but sometimes you may find me calling it as net acceleration. Remember that those sometimes will be only and only uniform circular motion. The reason is, in uniform circular motion there will be no tangential acceleration, hence the only acceleration you can deal with is centripetal acceleration, commonly also named as normal acceleration or radial acceleration. Okay, why normal, sir? Why normal? Normal means perpendicular. So the velocity is tangentially directed and acceleration, centripetal acceleration is radially directed. Definitely tangent and radius are normal to each other. And since it is radially directed, radially inwards, definitely you can call it a radial acceleration. So centripetal means center seeking, towards the center. Normal means perpendicular to the instantaneous velocity, and radial means along the radius. So centripetal, normal and radius, these are the names of the same acceleration whose responsibility is to change the direction, and tangential acceleration responsibility is to change the magnitude. Alright, I hope you got the idea. Let me take you to another one, and don't rush in copying the notes. Notes will be separately provided to you. Oops, we are having a problem with us. So let me brief you somewhat more, then we can talk about the problems too. Okay, so just the other things. Suppose I say if theta is the angle between net velocity vector, or you can also call it net velocity vector, or you can also call it instantaneous velocity vector, and net acceleration vector, then I repeat, if theta is the angle between net velocity or instantaneous velocity and net acceleration vector, then there will be several cases. Suppose I start with uniform circular motion. Here the particles, this is the particle, P particle. Here its velocity is like this. This is the instantaneous velocity. Okay, instantaneous velocity or net velocity means the same. Here is the net acceleration. This is the centripetal acceleration, and there is no tangential acceleration. So suppose say AT is 0, tangential acceleration is 0. So if tangential acceleration is not there, so the only acceleration you have is centripetal acceleration, can be called as a net acceleration too, can be called as a net acceleration, and hence the angle between the centripetal acceleration, the net acceleration and the net velocity is 90 degrees. So here theta is going to be 90 degrees, the angle between velocity and acceleration 90 degrees. So what you can say that here, since tangential acceleration is 0, the change in speed will not be there. Speed is constant, or velocity will be changing. Who is changing the velocity? Net acceleration. What component is being changed in velocity is only and only its direction because of the action of centripetal. There will be no change, I repeat, there will be no change in the speed. So speed is constant, or change in kinetic energy. Change in kinetic energy is equal to 0, or net work done is equal to 0, or power delivered F dot V, since the angle between the net force and the net velocity is 0, so power delivered, instantaneous power delivered is also 0, and average power delivered is also 0, that is delta W by, or change in kinetic energy by delta T, since nothing has been changed, that is also 0. But direction of velocity is definitely variable. Not only that, the centripetal acceleration or net acceleration is also a variable vector. That is also a variable vector. How, sir? So what you need to understand is that here we can say that net acceleration's magnitude is equal to centripetal acceleration magnitude is equal to v square by r or omega square r. V square by r, omega square r, that is constant. That is constant. Net acceleration's magnitude or centripetal acceleration magnitude, that is constant. But if you see the direction of centripetal acceleration, that is going to be variable. Direction of centripetal acceleration, that is going to be variable. Why you are saying like that, sir? Because when the particle was here, its velocity was here, and the centripetal acceleration was directed like this. When the particle was here, its velocity was here, and its centripetal acceleration was directed like this. So again, what I can say is that the magnitude is v square by r and v is constant. So definitely v square by r or omega square r is also constant. But magnitude is constant, direction is variable, hence the net acceleration is also variable. Net acceleration is also variable due to direction. Hope the logic is clear to you. All right. So this is all about UCM. This is the case of UCM, uniform circular motion. This entire is the case of UCM, uniform circular motion. That is the main type of circular motion in our syllabus. Uniform circular motion is the main circular motion of our syllabus, and hence we are focusing this much on that. Okay. What about the other type of circular motion, sir? So I have written a lot, but you need to understand each and every aspect carefully. So once you compare, you will be able to understand it better. Let me take you towards the another one. Let's see that this is the path in which the particle is somewhere here. Its instantaneous velocity is directed like this. Okay, its instantaneous velocity is directed like this, which can also be called as the net velocity. Okay, net velocity or instantaneous velocity is this. And suppose the tangential acceleration is also there. And centripetal acceleration is there. Okay, tangential acceleration is there, centripetal acceleration is there. So definitely the net acceleration is somewhat here. Net acceleration is here. And this angle between them is going to be theta. Net velocity and net acceleration, the angle between them is going to be theta. And you can see that angle is acute angle. What you need to understand here is that in the influence of AT, the speed will keep on increasing. If the speed will keep on increasing, the AC, which is v square by r, the AC value, which is v square by r or omega square r, will also keep on increasing. So in general, if tangential acceleration is constant, because of v square by r, the acute angle keeps on increasing. Because this component will keep on getting stronger. Okay, this component will keep on getting stronger. But anyways, let me talk about the other aspects first. First of all, I will tell you here, since tangential acceleration is supporting the velocity, so speed v will keep on increasing with time. This implies change in kinetic energy or net work done. Both are positive. Change in kinetic energy is equal to net work done, you can say work energy theorem. And instantaneous power, that is mod f, mod v, cos theta, theta being acute is positive, and average power, that is delta Ke by delta t, I will say both are going to be positive. Both of them are positive. What next, sir? The centripetal acceleration v square by r keeps on increasing, and hence the net acceleration is under root of AC square plus AT square. Okay, AC square plus AT square. I hope the acute angle, the moment examiner says acute angle, the entire situation will be quite clear in front of you. Now suppose we talk about the thirdmost one, in which the particle is moving in a circular path, and let us assume again that the particle is rotating in the clockwise sense. So I will say, suppose the particle is here at this point of time, and it is having its velocity vector in the forward direction. its velocity vector is suppose like this, which can also be termed as its net velocity vector. Now you will be saying that here the tangential acceleration is suppose opposing the velocity. Here tangential acceleration was not available. Here tangential acceleration was supportive, responsible for increasing the speed. Here tangential acceleration is opposing, responsible to decrease the speed. So centripetal acceleration is this, that will be equal to v square by r, and definitely that will keep on decreasing with time. Here it v square by r will keep on increasing with time. Here that will be decreasing with time. You will say the net acceleration is somewhat here, the resultant of the two. The net acceleration, which can again be given by under root of ac square plus at square. But this time what you need to understand is that the angle with the net between the net acceleration and the net velocity will be theta, which is obtuse, and as a result here instantaneous velocity will also keep on decreasing because it is facing some opposition. Here the net velocity vector will keep on getting stronger, its strength will increase, right? So what you can write down here is that speed keeps on decreasing, and this implies change in kinetic energy, net work done, power instantaneous or power average, all are going to be negative, all right? The centripetal acceleration will definitely keep on getting weaker. The centripetal acceleration v square by r or omega square r, that definitely will keep on getting weaker, and the net acceleration will be again given by under root of ac square plus at square. ac square plus at square. Remember, in any of the case, whenever you are trying to find out ac, that is v square by r or omega square r, whenever you are trying to find at, that is dv by dt or r alpha. dv by dt or r alpha, I'll give you a quick recap once again here. It is dv by dt or r alpha, or again I can write one more term, dv by dt or r alpha, or r alpha, or another term is v dv by dx, है ना? That can also be written as v dv by dx. I'll show you, just a moment. So it will be, another version can be v dv by dx or r alpha. So 8c can be v square by r or omega square r, 80 can be dv by dt or v dv by dx or r alpha, depending upon whether velocity is given as a function of time or velocity is given as a function of x, or you have to deal with the angular kinematics and linear kinematics together. Just take a quick recap, just take a minute, see everything written on the board. See everything written carefully. The responsibility of changing the direction is of centripetal, and the responsibility of changing the magnitude is of tangential. They will not interfere in each other's operation. All right. Next is, just take a minute and have a quick look of all of them, all the cases I have portrayed in front of you in quite detail. I hope that's cool for you. You have understood it, right? Okay. Chalo. Next. We are starting with the problems now. I have, taken 10 most predictable problems from this phase 2 of circular motion, that is kinematics of circular motion for you. So first one is a cyclist riding with a speed of 27 km per hour. A cyclic riding with a speed of 27 km per hour. As he approaches a circular turn on the road of radius 80 meter, he applies brakes and reduces his speed at constant rate of something every second. The net acceleration of cyclist on the circular turn is. So what they have given is, see, first of all, they are telling you the velocity. Velocity is 27 km per hour. Oh, that's 27 km per hour, kmph. So, or that can be written as 27 into 5 by 18, okay. So if you cancel it by 9, this much of meter per second, or that can be taken as, if you cancel by 9, it is 9 into 3, 27, 9 into 3, 27, 9 2s are 18. So you got 3 into 5, 15, 15 by 2, 15 by 2 is 7.5 meter per second, 7.5 meter per second. And radius is 80 meters, radius is equal to 80 meters. So the centripetal acceleration will be equal to V square by R. V square by R. So that is 7.5 into 7.5, or you can say 7.5 square by 80. By 80, definitely you can get that. Okay, I'm leaving, as of now, I'm leaving the calculation step. The next thing is they are saying that also the tangential acceleration, which is dv by dt, rate of change of speed, acceleration or retardation, whatever it is, 0.50 meter per second every second. So it is dv is 0.5 meter per second and dt is every second, means 1 second, and hence that is 0.5 meter per second square. 0.5 meter per second square. If you are having AC2, if you are having AT2, AC you are also having, and AV2 you are having. So A net can be calculated as under root of AC square plus AT square, and hence you can get your answer. I suppose this value is going to be very, very less even if you try to simplify it, because it's something like 7.5 ka whole square by 80, 7.5 ka whole square by 80. So it is 7, 7, 49, 8, 8, 64. It will be lying somewhere near about 55, 56 like that. If you divide by 80, definitely it is approaching 0. Like almost half. So 0.5 and 0.5 approximately, I think if you will approximate it, you are going to get it as 0.87. You can just check, rough calculation kar lena and spare me for any random guesses I am trying to make. But yes, this is the problem and that's how you should be approaching it. Hope you got the idea. In the final exam, if they are expecting some sort of calculations from you, then they won't be asking you any weird calculation. That in the middle what we got. Okay, so you can expect a relatively simpler calculation than this. This was the first example. I have mentioned it example 11 in a hope that you have gone through the angular kinematics completely, in which we have taken care of 10 examples there. Taking you to the next one. A stone tied to the string of 1 meter long is whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, what would be the magnitude and direction of the acceleration of the stone? What would be the magnitude and direction, I will say, of acceleration of the stone, Okay, slight editing is required here, I think. Now how to take care of it? I will say given speed is constant. If speed is constant, this implies tangential acceleration is 0. So the net acceleration will be equal to only centripetal acceleration magnitude, and the vectors are in fact equal, and you will say that will be V square by R, or 22 revolution per second hai. That can be written as omega square R and towards the center. Omega square R towards the center. Omega is 22 revolution in 44 seconds. So 22 revolution, one revolution can be written as 2 pi radian. Okay. So 22 revolution stands for 22 into 2 pi radians by 44 seconds. So what I have taken is theta by t, delta theta by delta t, that is omega, it's square into R, and towards the center, naturally, So you will say radius is how much given here? I missed that. Radius is how much given? Radius is 1 meter long. So that is 1 omega square R, and the direction is towards the center. So that is 22 into 2. 44 by 44 is gone, and it is pi square meter per second square, and it is towards the center. Centripetal means center, seeking towards the center. You can also call it radial acceleration as well as the normal acceleration. Centripetal acceleration, radial acceleration, or normal acceleration. I hope that's fine. Hope you have understood this. Don't rush to copy the solution. Look at it so that you get the idea of all the problem models. Notes are provided separately. Okay. Next is in the given figure, acceleration is given to you 15. You would have recently faced this type of problem in the exam. Acceleration is given to you. I will say there is the centripetal component AC here, and there is a tangential component AT here. So what you can do is, here you can write the centripetal acceleration AC, which is supposed to be v square by r, that will be equal to a cos 30 degrees. है ना? The vector will be making 30 degrees with the axis, so that's a cos 30 degrees. What they are asking you is the speed of the particle. So v square by r is equal to 2.5. That is equal to a, that is 15, and cos 30 degrees is root 3 by 2. Root 3 by 2 value is 0.866. The people who don't know, I'll tell you, 1 by root 2 is a very common model that common data that comes in trigonometric functions. So that will be 0.707. And similarly, root 3 by 2 is another common data. Its value is 0.866. So from here, if someone is asking the value of v, then I will say 2.5 should be multiplied, and ultimately it is under root. We will try to do some sort of smart calculations. It is 15, root 3 by 2 is 0.866. Root 3 by 2 is 0.866, and if you multiply 2.5 over there, you'll get 25 by 10, okay, 2.5. So out of all this stuff, you can take 25 outside the root, that's 5, under root of, if you take this 15 into 0.866, suppose you did 15 into 8, that is 120, and 15 into 9, that is 135. So can I say it is 0.866, something in the middle? So it will be approximately 13 by 10, 1.3. So you can say 5 into root 1.3 means something slightly greater than 5. If it is slightly greater than 5, slightly greater than 1 here, है ना? Under root of 1.3 slightly greater than 1 here. So obviously the final answer will be slightly greater than 5. Slightly greater than 5, the correct option, the only option you have in front of you is 5.7. So yes, the way I said in 1 or 2 problems back that you cannot expect that much weird calculation in the exam, but sometimes the calculations are like that look a bit weird, but if you are using some smart approximation, you can easily get that idea. I hope the problem is clear to you. All right, understood that? Chaliye. Let us talk about another one. Example 14. A particle moves along a circle of radius 20 by pi meter. 20 by pi meter. Just increase its font size. 20 by pi meter with constant tangential acceleration. Tangential acceleration is given constant if the velocity of the particle is 80 meter per second at the end of the revolution after motion has begun. The tangential acceleration is, let us start the way you always start, with a question. Let us write what is given to you. A lot of data is there. Radius is given to you as 20 by pi meters. Constant tangential acceleration is there. At the end, after motion has begun, so initial velocity, you can take the initial velocity is 0 meter per second. Final velocity is 80 meter per second. And at the end of second revolution means they are talking about the theta value. Second revolution means that is 2. I mean, if you want to convert it into the linearity, S considering linear. S considering the linear motion. It's not a linear one, it's a circular one. So if you consider it to be a linear motion, a straight line motion in which instead of revolving in a circular path, if a particle keeps on going on a straight line, then distance and displacement are going to be equal. Means displacement will be given by the actual path length. They are saying second revolution, 2 into 2 pi r. So that will be equal to 4 pi. The value of r is given to you as 20 by pi. 20 by pi. I think pi will be cancelled. It is 20 into 4, 80 meters. 80 meters. So what they are asking you is the tangential acceleration. So what you can do from here, can I clearly say the value of 80 will be equal to v square minus u square by 2s. Okay, third equation of motion, v square equals to u square plus 2as, out of which this u square is 0. Okay, so tangential acceleration is v square. V is how much? 80. 80 ka square by 2 into this was also 80. So 180 will be cancelled, remaining 80 by 2. I think the answer is 40 I missed the value. Pi also kya? No, I didn't miss it. So it is 40 meter per second square. 40 meter per second square. Just check out the calculation. And if one or two calculation, if by mistake those are wrong, please try to focus more on the concept and spare me for any one or two minor mistakes if they are happening on board. Okay. So anyways, I hope you got the idea. What we did in this particular problem, we only talked about now the major doubt of the students in this problem is, sir, if a particle is moving in a circular motion, even at the end of the duration, its displacement is zero, na? Because initial and final points are same. But what I said is, particle is indeed moving in a circular path, but you are assuming that you are converting that circular path on a straight line. So if the particle is assumed to move in one rotation, the particle has moved from here to here. Another rotation here to here, another rotation here to here. So you are assuming that instead of dealing with a circular motion, if you are considering a straight line motion, then it's a unidirectional one. The distance and displacement can be treated to be same, right? I hope that doubt is also now sorted. Another problem. A particle moves in a circle of radius 5 centimeters with constant speed and time period. The acceleration of the particle is, constant speed is given and time period is given, and they are asking you the acceleration. So sir, which acceleration they are talking about? So I will say here net acceleration is given as under root of AC square plus AT square, because they are talking about magnitude and magnitude, out of which if its speed is constant, then AT is 0 since speed is constant. What does tangential acceleration do, sir? Tangential acceleration changes the speed. If speed is not variable, the tangential acceleration is not there. So that's AC, and hence the AC can be written as omega square R or V square by R. Okay, so what is given to you? I think the time period is given to you. So you can write it as omega as 2 pi by t. 2 pi by t, its time period is given to you. So omega can be written as 2 pi by t, its square into R. So let us put all the values. So it is 4 pi square and the time period is given to you as 0.2 pi. Let me do it like this only. 2 pi by 0.2 pi and its complete square, and the radius is 5 centimeters. So that's 5 by 100. Okay. So 2 pi will be cancelled by 0.2 pi at 10 times 10 square 100, and this 100 will be cancelled, and hence the final answer should be 5 meter per second square. So the correct option is option D for you, 5 meter per second square. Easy hai? You got the idea? So this completes our 50% journey of the kinematics of circular motion. The next 5 problems are going to be much more relevant and probable for the exam. Okay? So have some patience, stay focused. Let me take you to the other one. Now, an electric fan, already a PYQ, has blades of length 30 centimeters as measured from the axis of rotation. So blade length is given to you, which can be serving as the radius for the tip. If fan is rotating at 1200 RPM, means this is constant value given to you. If constant angular velocity or velocity is given to you, this implies the tangential acceleration is going to be 0. No tangential acceleration. And what they are asking you is the acceleration of a point on the tip of the blade is about. So here we can write again, A net will be equal to under root of AC square plus AT square, out of which tangential acceleration is 0 because it is constantly moving with that much speed. So that will be equal to AC, which can be written as omega square R or V square by R. Now if you see, they are asking you the acceleration of a point and this omega value is given to you. So omega is 1200, but that is not in the SI form. It is given in revolution per minute. Do remember to convert it into radian per second. So 2 pi by 60. 2 pi by 60 and its square. Okay. 2 pi by 60 RPM into 2 pi by 60 and its square into R. The radius is 30 centimeters. So 30 by 100. So that every answer will be in every parameter is in SI, so that the final answer will also be in SI units. So naturally, you will say, sir, 1010 cancelled. 120 will be cancelled by 6 at 20 times. 20 into 2, or you can say, it is 0 ka square, 10 ka square, 10 square, and this 100 will also be cancelled. So you can cancel this 1 0 by these 2 zeros. The reason is here it is 1 0 ka square, 10 ka square, 100, and this 100 will be gone. Now the things have been a bit simplified. 12 will be cancelled by 6, 2 into 2, 4 pi square. So it's going to be 4 pi whole square into 30. So that is approximately 16 pi square. Pi square can be treated as 10, or it isn't pi square. No, it can be treated as 10. Pi square can be treated as 10, and it is 30. So I will say it is approximately 16, 3, 48, 4800. So it is approximately 4800 meter per second square. Do remember it's an approximate answer. If you put the exact value of pi, 3.14 square, you will get near to 48, and hence the final option is 4740, approximately 4800 meter per second square. Hope you got the idea. This problem was exactly similar to the previous one. What did we learn is about the language. If they say something is happening at this rate, means the rate of occurrence is constant. A body is moving with a certain velocity, which means a body is moving with that certain constant velocity. Alright? Chaliye. Next problem, a good one. A particle moving along a circular path in the xy plane. When it crosses x-axis, it has an acceleration along the path. It crosses x-axis, it is going down. It has an acceleration along the path of 1.5 meter per second square, and is moving with a speed of 10 meter per second in the negative direction, down 1. So the net acceleration they are asking. If the figure is not that much clear to you, let me redraw it for you. I'm redrawing it for you. This is the figure. And they say when the particle crosses the x-axis, it's moving down, negative direction. So this is the particle. It is moving down with speed given as 10 meters per second. And its acceleration is along the path. Along the path is 1.5 meter per second square, which means it will be this tangential acceleration along the path, that is 1.5 meter per second square. Can I say it will be having another acceleration? Another acceleration will be centripetal acceleration. This centripetal acceleration will be v square by r, and that will be equal to v square. That means 10 square by r. R is r, how much it is? Radius is 2 meter given in the figure. If not visible, I am drawing it once again. So that is here 2. So naturally 10 square 100 by 2, you are going to get 50. This is 1.5, very less in comparison to 50. This is the 50. What they are actually asking you is net acceleration. So I will say here net acceleration in vector form, that is AC vector plus AT vector. If you notice, the centripetal acceleration is in minus I cap, so that is 50 minus I cap, plus tangential acceleration is already given along the path, so that is 1.5 minus j cap. Okay, so 50 minus I cap, 1.5 minus j cap. So 50 minus I cap, 1.5 minus j cap. I hope the correct option is option A. Now, interesting questions again. A particle moves on a circle of radius r with centripetal acceleration is given to you, but they are asking you find the following quantities as a function of time at an instant. So first thing is what given to you? AC is equal to k square RT square. They are asking the speed of the particle. These are not the 4 options. This is a very important question. Very important. These are not the 4 options for you. These are the 4 parts of the problems which I want you to determine. Okay. So first thing is AC is a k square RT square, that is given to you. They want speed. So this can be written as V square by R, that is k square RT square. This implies V square is equal to k square R square T square, or V will be equal to KRT. V will be equal to KRT. This gives you answer of A part. Now they say the tangential acceleration of the particle. Now I will write tangential acceleration, that is dV by dt dv by dt. So d by dt of v, that means kRt. So definitely it is going to be kr, and t's derivative with respect to t is 1, so that is equal to kr. So this is going to be the result of tangential acceleration, what they have asked you, which means part B, kr. Okay. Now they are asking you the resultant acceleration. Now resultant acceleration A net can be written as under root of AC square plus AT square. So that will be under root of AC is given to you as K square RT square, and we are having its whole square, plus AT square is K into R, and we are going to have its square. Okay, I hope you got the idea. So what you can take common is, I think K into R can be taken outside, and it is under root of 1K will be remaining and T square will be remaining. 1K will be remaining and T square will be remaining, at its square will be available. So remaining K its square is K square, remaining T square its square, T to the power 4. So K square T to the power 4 plus 1. K square T to the power 4 plus 1, K are taken common. So I think this is the answer of the C part, what they are asking. And they are asking the angle made by the resultant with the tangential direction. The angle made by the resultant with the tangential direction, we need to see this, that here the particle is moving. The particle is moving with this tangential acceleration, that is given by how much? Tangential acceleration is kr. Tangential acceleration is kr. All right. And then it is centripetal acceleration. Centripetal acceleration is K square RT square. So naturally its resultant will be somewhere here, A net. And they are asking you the angle made by the resultant with the tangential direction. This resultant with the tangential direction, they are asking you this angle phi. So can I say here tan phi will be, remember, if you are taking the angle with T tangential, then tangential component must be coming in the denominator. I repeat, because that will be serving as base. So tan theta will be perpendicular by base. If you are taking the angle with the tangential component must be coming in the denominator. So that will be AT, which is KR, and it is AC in the numerator, that is K square RT square, So you can see the K and K value, R and R value got cancelled, K and K value got cancelled. Phi value came out to be tan inverse. That is remaining K and T square. Okay, so this is the value of angle phi, what you got. I hope the entire problem is clear to you. So these were not the 4 options. I told you the complete cycle, that even if they are directly asking you the angle, definitely you have to go through all of them. So even if they ask or they don't ask, anything in between like that, but the actual process you have to go through is this. They will give you the centripetal, that will give you the speed, differentiated, that will give you the tangential, take under root of AC square plus AT square, that will give you the net acceleration. Getting the value of AC and AT separately, you can also get the angle. I hope the story is clear. Have a look. Take your time, have a look carefully. All right. I hope you got the idea. Chaliye. Last 2 problems. It's very important problem. Crucial hai, rarely expected in the exam, a bit crucial, but I'll tell you how to do. Just listen to me. A particle is given, the velocity is given to you. They are asking you the tangential acceleration to that of the total acceleration. So step by step we are going to do that. First of all, V vector is equal to 3 I cap plus 4 T j cap. Okay. So the net acceleration, what you are going to have is dv vector by dt. So you can see that it is equal to, I'll write it here. You can see that this is equal to the 3 derivative here is going to be 0, it's constant, plus 4 will stand as it is, its derivative is this. So what you got is 4 j cap. The net acceleration is 4 j cap. So net acceleration at t equals to 1, this is constant, right? This is constant independent of time. Net acceleration at t equals to 1 will still remain 4j cap, and net velocity, instantaneous velocity at t equals to 1 is going to be 3 i cap plus 4 into 1 j cap, which can be directly written as 3 i cap plus 4 j cap. Okay, this much of meter per second, this much meter per second square. Now you got the net velocity, you got the net acceleration, you have to find out the tangential component separately as well as the centripetal component separately. Let's go for the visualization. We will say the acceleration here is given to you like this. The acceleration here, net acceleration here is given to you like this. It's in J, so that is 4 units, and net velocity is given to you as if it is having 3 i cap and 4 j cap component. So 3 i cap component here, 4 j cap component here. So this is your net velocity. This is your net velocity, V net, definitely under root of 3 square plus 4 square, that will be 5 units. And what will be this angle? This angle here is going to be 53 degrees. J cap component is bigger, I cap component is smaller. So this angle here is going to be 37 degrees. Can I say the net acceleration will have a one component here parallel to the velocity? That will be called as tangential component, and that should be equal to 4 cos 37 degrees. 4 cos 37 degrees. And there will be one component perpendicular to the velocity. There will be one component parallel to the velocity called tangential, and there will be one component perpendicular to the velocity called centripetal. So that should be equal to centripetal or normal or radial, that should be equal to 4 sine 37 degrees. Sine 37 degrees is, let's take the ratio. Finally, what they are asking is, you the ratio of tangential to the total. Okay, the ratio of tangential to the total. So A tangential by A total. A tangential is how much? 4 cos 37 degrees. A total is how much? That is 4. So that is cos 37 degrees. 4 got cancelled. Cos 37 is 4 by 5. And hence your correct answer is 4 by 5, 4 by 5, option A. I hope you got the idea. Why I told you AC, sir? Because it's a common model. It's a common model if required. If they are asking you regarding that, determine the centripetal to tangential ratio or tangential to centripetal ratio. Again, you can take the ratio 4 sine 37 by 4 cos 37 or cos by sine, vice versa, depending upon the demand of question. So what was so interesting regarding this particular problem is that velocity was variable. You differentiated the velocity, so you didn't get any one of the acceleration. The total velocity vector will be changed by net, the magnitude will be changed by tangential, and the direction will be changed by centripetal. So you got the net velocity, you got the net acceleration, you found the angle between them, they were not collinear. One component of the acceleration will be collinear to velocity, that should be termed as tangential, and one component should be normal to the velocity vector, that should be termed as centripetal. Okay, so that's what we have learned in this second last problem. Have a look, then we will complete our journey with the last problem. All right, I hope you got the idea. So this is the last problem, a bit longer one, but definitely we will be following the steps. So we are going to get the correct result. It just looks complex. Okay, so let us complete the story with this discussion. A particle moves in a circular path such that its speed v varies with distance as given. So what is given to you? Given that v value is equal to alpha root s. V value is equal to alpha root s. Find the acceleration of the particle after traveling a distance s. They are asking you the acceleration, which means they are asking you the net acceleration. So you have to talk about both, sir. We have to talk about both of them. So here I will write first of all centripetal acceleration. So centripetal acceleration is v square by r. So that is equal to alpha root s ka square by r, and hence that is equal to alpha square s by r. Centripetal as acceleration is done, sir. Tangential acceleration can be written as dv by dt. if the velocity is given as a function of time, or that can be written as v dv by ds if the velocity is given as a function of s, and it is clearly visible here, the velocity is given as a function of s. So that will be equal to v means alpha root s into d by ds of alpha root s, okay, v dv by ds. So you will say alpha root s is already there and another alpha will come out. So this will be alpha square root s, and d by dx of root x is 1 by 2 root x. I repeat, d by dx of root x is 1 by 2 root x. So it is going to be 1 by 2 root s. Root s will be cancelled and it will be alpha square by 2. So see, you got AC, centripetal acceleration, you got AT, tangential acceleration, and finally, they are asking you the net acceleration until or unless mentioned which type. You are bound to take net acceleration. So that AC square plus AT square. So that is under root of AC square alpha square s by r its whole square plus alpha square by 2 its whole square. So if you look at it carefully, the alpha square term can be taken common, it will come out under root of, it is s by r ka square, that means that is s square by r square, plus it is 1 by 2 ka square, that means 1 by 4. So alpha square will come out, and there has to be a positive sign within. Alpha square will come out and there will be a positive sign in within. So A and C are eliminated. Now out of B and D, we have 1 by 2 here and 1 by 4 here. Obviously, the answer is going to be option B. I hope you got the logic. So this was again a problem. Looking at this problem in the exam might give you some sort of fear or complexity that whether you will be able to deal with it or not. But trust me, if you are going to deal with it step by step with the method we have learned in the previous 10 problems, it's gonna be easy. Have a look. All right. I hope you have got the idea. So notes are separately provided to you. Make sure that you look for these problems and quickly try to learn them. Okay. So now we are done with 2 phases of circular motion. First one was angular kinematics. Second one was kinematics of circular motion. The other 2 phases are upcoming, and those are going to be dynamics of circular motion and conservation of energy in vertical circular motion. All right. Till then, all the best.